Friday, you were working on 5.1 on radicals. Today we carry on. We had the very basic stuff on Friday, talking about exponents, changing radicals to whole radicals to mixed radicals and back. Today what we want to do is we want to look at multiplying and dividing radicals. So if I have 2 root 2 times 4 root 5, okay? You can only multiply whole numbers by whole numbers, and you can only multiply radicals by radicals. And they can change. And then you simplify your radical after the fact, or you can simplify it as you go. It's up to you. Alright, so this one would be 2 times 4 is 8. Root 2 times root 5 is square root 10. And that would be a final solution for that. Okay? So on page 200, we'll look at the working example there. 3 root 5 times square root 10. Okay? So put brackets around both of them. Not necessary, but we'll do it anyways. Alright. So, yeah, exactly. 3 root 50. Now, is there a perfect square that goes into 50? 25. 25 times what? Okay, what's the square root of 25? 5. 5 times 3 is? 15. So I have 15 square root 2. Okay? Now, I could have done this one a little different. I could have done this. 3 root 5, root 5 times root 2. I could have broke 10 down because I saw that I had a square root 5, and I know that there's a square root 5 in root 10. So I could have done this. So then I had root 5 times root 5, which is root 25, which is just what? 5. Root 5 times root 5 is 5. 5 times 3 is 15. And I'd be left with root 2. So that's another way to do it if you want to do it a different way. Okay? So let's look at B now. Okay? Again, because there's a variable in there, they state that you have to have x as a value that's greater than 0. Okay, but for us, we just want to simplify this. So first things first, 2 times 4 is 8. Root 14 times root 7. X to the 4. Good. Okay. Now we got to simplify. What's the perfect square that goes into root 98? Don't use your calculator.
49.
What is it?
49.
49. Now, take a look at the first two numbers I multiplied to get there. It was 7 times 14, right? And 14 is 7 times 2. So I'd have 7 times 7. So yes, I'd have 8 square root 49. Square root 2. And what is, sorry, I'm going to wrap this up just 1 second here. So, what is the square root of x to the 4th? X squared. So I put the x squared on the outside, and then I'm left with root 49 times root 2. What's the square root of 49? 7 times 8. Okay? Questions?
Can we do a couple of those like how we did last time, where like you put it in like our own?
Yeah, sure. Okay. I'll try one here. one isn't in your book. This one's not in your book. So if you want to try this on your own. Okay. So, your first step. 5 times 3 gave me 15. Root 6 times root 12 gave me root 72. 8 times a to the 5th is a to the 6th. How many got there? Who did not get there? Anybody not get there? It's okay, I just want, see? You got there? Okay. Alright, so now, a perfect square that goes into root 72 probably has something to do with 6. Root 36 times 2 is 72. A to the 6th I just wrote right there. Square root of 36 is 6 times 15 is 90. Oh, I put an X instead of an A.
I have a question. Why would it be x or a cubed if you have to take the square root of a?
Okay, I'll get to that in 1 second, okay? And then I leave the square root here. How many of us got this right? Okay, who did not? All right, where do we go wrong?
I'm not in separate, to put the a separate.
Okay? I'm going to explain that part in a second. Petra?
I got a squared, not a cubed.
You had a squared, not a cubed, okay?
I forgot to divide the 7 cubed by 2. This is equals.
Okay? All right. Let's focus on the square root part here. That is a to the 6th to what exponent?
1/2. Oh.
1/2, right? So now I multiply the exponents because it's a power to a power. 6 times 1/2 is 3. So that's how I got 83. Does that make sense? Good so far? Any questions about it? Yes, Brittany.
Why is the, like, does a cube have to go on that side? Like, why is it on that side?
Because this, even though it's a variable, I consider it a whole number. It means I no longer have the square root. And if I no longer have the square root, they always go in front. It should always be written with a coefficient or the variable that has the square root been taken care of already. And then once it's out of there, then I just leave the square root on whatever's left, the radicals that's left. Okay? So if I have, for example, like this, square root 50, that's root 25. root 2, right? The first number is the whole number. It always gets written first. So I get this. So if I have this, let's say, square root of b cubed, that's square root b squared times square root b, like that. Okay? What's the square root of b squared?
B.
So it's written as b root b, like that. So once you have reduced it using the exponents, it stays on the left side of the radical.
Okay.
Does that answer your question? Okay. Yes, Rex.
So you do the same thing if you have like a to the 7th?
Yes.
Okay.
Yeah. So then if I had a to the 7th, Rex, that would mean
A to the 6th, and then 8 cubed root 8.
okay. Yes, Eli.
So how did you get the 90 there?
The square root of 36 is 6.
Yeah.
So it's now a whole number. So I have to multiply by the other whole number, which is 15.
Oh, I see, okay.
6 times 15 gives me 90. Okay? Any other questions about that? Alright, now I'm going to show you a different one now. Using the distributive property. Okay. So using the distributive property, what am I supposed to do here?
If them, equal to root 6, the ones in the brackets. So like root 10 or root 6, I guess you can make the equal to. Are you picking up on that? Like when we did like add and subtracting last time, we could only add the radicals.
Yeah, okay, yeah, no, I understand that. Yeah, if it was possible to do that, sure. Okay, that would be one way to do it. If you could make them have the same root value. Yeah, okay, that's good. But we can't do that, so then what's the next thing to do? Yeah,
You distribute the root 3.
yeah, I'm gonna distribute the root 3 now, and then I'm gonna shrink it and see what I get. Okay, so to distribute the root 3, I have to times it by this, and then the root 3 has to times by that. So what's root 3 times negative 5 root 10? Very good. Negative 5 square root 30 plus root 18. Can I break down 30? Is there a perfect square that goes into 30? Is there a perfect square that goes into 30? Go through your perfect squares quickly. 1, 4. Does it go into 30? 9?
No.
No? 16? 25? No. Okay, so it has to stay as root 30. That's okay. Square root of 18 is
9 and 2.
9 and 2. What's the square root of 9?
3.
So 3 square root 2. And that's your final solution. You don't have to do anything else with that. Any questions about that? Okay? These are pretty basic ones. Alright? So then the next step after that, so we've distributed through. The next step after that is to do a binomial by a binomial. But instead of using variables, I'm going to use radicals. So, let's see how you make out here. Somebody tell me, first of all, what you would do. What's the process to do this? Without doing it, what's the process to do this?
Figure out the 2 brackets.
Oh, yeah, foil. Foil. That's probably your best bet. Okay, so you need to foil this. Again, multiply the whole numbers by the whole numbers and the square roots by the square roots. Just start with that. Okay? So I want you to do that right now. I want you to start with that and see what you get to begin with here. I'm gonna multiply the first one. So I'm gonna show you, you can do this one of two ways. Me personally, the same way I work with fractions, I like to reduce things immediately if I can. It makes my math a lot easier. So what I'm talking about is this. So the first thing I have is 5 times -4, right? Which is -20. Okay, what is the square root of 2x times the square root of 2x? Yeah, see that's what I would do. How many of you put root 4x squared? Okay, that's okay. If you do it that way, that's fine. Alright? But anytime I take a square root and I multiply it by the same square root, it just becomes this. So if you took the square root of 4, what do you get? 2. And what's the square root of x squared? X. So I still get 2x. So you can do it your way, that's okay. You would just take one extra step.
So if
Alright?
you have fractions, you can reduce.
Yes. Yeah. Okay, so now I've got outside. So 5 times 1 and root 2x times root 5x is going to give me 10x squared. So I'm just going to leave that as this for now. Then the inside is root 5. So I've got subtract 4, and then it's root 5 times root 2x, which is root 10x. And then I've got plus root 5 times root 5x, which is root 25x. Okay. So have a look there. Okay. So some of you would have had root 4x squared there. But the rest of that should have looked like that. How many of you got that far and got it correct? Alright. Eli, no? What did you have wrong, Eli?
I went in brackets and then multiplying the brackets never. It's just like one set at a time. Try to make two things in each bracket.
Okay. But you have an add and a subtract in there, right?
Yeah. Well, two adds.
Or two adds, but you can't do anything with them because they're not the same square roots. So you have to FOIL this. All right. So do you understand what FOIL means?
Yeah, so you have to multiply those and FOIL.
Yeah. Okay. Anybody else? Who else had errors here? Just trying to find out what the errors and eliminate them. Okay. All right. So then right here, my next step is to multiply this. Well, this is all a whole number here, right? So I get minus 40x. So that guy's taken care of. It's as small as it can get. Plus 5. Can I break down root 10? Is there a perfect square that goes into root 10? Or into 10? No. So it has to stay as is. What about square root of x squared? What is it? Okay, so I'm going to make that 5x here. Square root 10. Any questions about going from here to here? Alright. I can't do anything with that, so it stays as this. Alright. Can I take the square root of 25? What is it? 5. So I get 5 square root x. Then the last thing I do is I look at it. Is there anything that has that is similar, that is alike? Nope. None of this is the same. I'm done. Right there. I can't add or subtract any of these because none of them are exactly the same with variables. The variables have to be exactly the same. The square roots have to be exactly the same in order to do that. Okay? So there's your final answer for that. Questions? Okay, we're going to do one more. So this one introduces some cube root work with you, but it doesn't change anything that we've already done. So I've got 7x cube root 8xy squared okay. So, just a note, if I have this, I can't multiply those together. They have to be the same rooted value. So this is a 2 and this is a 3, you can't multiply those. But in this case, I think we're good. Alright, so what's the first thing I need to multiply together here? 7x and 3, which gives me 21x. Then I get the cube root of, okay, 8 times 8, 64, x cubed, y to the 4. So far so good? Alright, so the last step is to break this down now. 64. Does anybody recognize it? What do we know about 64? It's a perfect square and a perfect cube as well. It's one of those numbers. Not many of them. Okay? What is the cube root of 64? 4. I gotta times that by 21. So I get 84x. So far. What is the cube root of x cubed? X. Agreed? So I'm going to have to times it by that x. So I go x times x, which gives me x squared. What's the cube root of y to the 4th? Alright. What do I got to do with this guy?
Put in as many multiples of 3 as you can, so it'd be
Remember that from Friday? Okay, so what's the cube root of y cubed? Y. And then I'm left with cube root y. There is my whole answer. Alright. So the x squared is the only part that, if you look from here to here, might be confusing. The cube root of x cubed is x, and then I have to times it by the x in front, which makes it x squared. Okay? Any questions? We okay? Alright. We do the same thing with division. Okay. Alright, so I can only multiply roots by roots, and I can only multiply whole numbers by whole numbers, and I can only divide doing the same thing. So, square root 15, I might change this. I may change this to this. And work it that way. Okay? So now I have a fraction. What's 15 divided by 5? 3. X divided by x? 1. And then y stays as is. There's my solution. Alright? Any questions so far about that? Pretty straightforward. Now, we've done this last year, and I'm going to talk about it right now. I'm hoping somebody remembers this. What is the one thing that I don't want to have? There's one thing for sure, yes, no decimals. What's the second thing that I should not have when I'm looking at a value? You should not have a square root on the bottom of a fraction. Okay? We don't want a square root on the bottom of a fraction. So we need to do what we call rationalize the denominator. And by rationalize, I mean we have to somehow change the denominator so it does not have a square root on the bottom. And since it doesn't have a square root on the bottom, I have to multiply it by something that isn't going to change the question either. So to rationalize this denominator, I'm going to do this. Multiply by the square root that's on the bottom. The top and bottom. I'm going to multiply by root 3 over root 3. What's root 3 divided by root 3? 1. So I'm not actually multiplying it by anything, am I? It doesn't change the question. What it does is it changes the look of the question. So now what do I have here? 8 square root 15. And on the bottom, root 3 times root 3 is what?
Root 9, so you can go to the-
What's root 3 times root 3? Pardon me? What's the square root of 3 times the square root of 3? 3. Root 9, which is 3. That's the whole point. Root 3, when I multiply it by itself, I get a whole number, right? So 3 times 2 is? 6. That's right, Isaac. So I get this, and then I reduce my fraction. So this is what we call rationalize the denominator. And to do that, I multiply the bottom by the same as the square root. But it's not that easy. It is when I have single values, but what happens when I have a subtractor and add on the bottom? So I have this now. Okay. I need to multiply this bottom by something so that I get rid of the square root. So I want to rationalize it. I'm going to introduce two new words. Rationalize isn't new, we talked about it a bit last year. And I'm going to introduce a new word by the conjugate. Basically what that is the additive inverse of whatever's on the bottom. So instead of multiplying by 5 root 3 subtract root 2, I'm going to multiply by 5 root 3 plus root 2. Okay? So I'm going to show you why. What happens if I multiply a minus b by a plus b? What do I get?
Difference of square.
I get difference of squares, right? Which is a squared minus b squared. Agreed? So if I multiply root 2 minus root 3 by root 2 plus root 3, I get root 2 squared minus root 3 squared. What happens with those squares and square root values?
They cancel out.
They cancel out. So what am I left with? 2 subtract 3, which is -1. Right. So this is why I multiply by what we call the conjugate. So now I'm going to multiply the top by 5 root 3 minus root 2, sorry, plus root 2, and 5 root 3 plus root 2 on the bottom. Okay? So multiplying the 7 through on the top, what do I get? 35 square root 3 plus 7 root 2. Okay? So I multiplied the 7 by this and the 7 by that. Now I'm going to multiply these two together. So what do I get? 25 square root 3 times square root 3 is just 3 minus 2. Square root 2 times square root 2 is 2. So now I gotta simplify. 35 root 3 plus 7 root 2. 25 times 3. 75 subtract 2. 73. There it is. Alright? Okay. That's all there is in 5.2. Quite a bit of work there. it'll start off easily with some easy ones, and then it'll get a little bit more difficult as you get into question 4s and 5. All right? You have the rest of today to work on 5.2. So I've got about 40 minutes today to do that. Are there any questions before I go? Yes, Eli? You have questions from the other day? Yeah, sure.
Number 5B.
Page 195,
194.
194. 5B, which one is larger?
Yeah.
Okay. So let's break down square root 300. What's a perfect square goes into 300? 100 does, yeah. Square root 100 times square root 3, which is 10 root 3. Agreed? Okay. The next one is what? 3/10?
Yeah.
So we already know that's smaller.
3/10 is
3/10
35.
root
The
three-
square root of
3,500.
Oh, square root 3,500, okay. So let's break down 3,500 again. Let's use the same thing that you just did. So that's going to give me 3 over 10 times 10 root 35. Which is going to give me 3 square root 35.
So, how did you get? Oh, I see. Oh,
You okay? Alright, what's the last number? There's 18, right?
yeah. And then 9 square root of 15 over 4.
9 square root of
15.
15 over
divided
4.
by 4.
Yeah? Okay, so that's going to give me 9 square root 15 over 2. Square root of 4 is 2, right?
Oh, I see. Not square root of 15.
Okay, so now I'm left with 9 over 2 square root 15. Okay, so let's see if we can make sense of this now. Alright? Approximately, what is the square root of 35?
5.5.
It would be more than that, right?
5.92.
You can't use a calculator. So I'm saying approximately, but yeah, okay. Well, I'll use 5.8. So I have 5.8 times 3. Okay, so that's like what? 16.4 maybe? Something like that? Approximately. Okay? 10 square root of 3. The square root of 3 is about 1.5. So we'll say that this then is 10 times 1.5, which would give us what? 15. Okay? And then this would be 4.5 times square root of 15, which would be 4 and a bit. 4.1, let's say.
Would be less than
3.9.
3.9, right? I'm sorry, I went ahead instead of behind. So 3.9, let's say. So that's basically 4.5 times 4. Right? What is 4.5 times 4? Approximately 18.
So, it's all pretty straightforward except for the 9 square root. Like, 15
Okay.
over 4.
So square root of 4 is 2, right?
Get there.
So I can 9 over 2.
Yeah, that's simple. And then after that.
So it's 4.5. 9 over 2 is 4.5.
Yeah.
I'll write that there.
Oh, I see. Yeah.
The square root of 15 is about 3.9, which is almost 4, right? So I got that. So this would give you a rough idea as to how you could.
I'm just wondering why you switch the 2 from under the square root of 15 to the 9.
Because it's a whole number. it's a half, well, it's not a whole number, but it's a natural number, well, it's a real number. Because I no longer have the square root. So it becomes 9 over 2, so it's like a half. Okay? Does that make sense?
Yeah.
All right, were there any other questions? Tired people's in here today? All right, go to work then.
How did you have